Alright, so if you haven't watched the previous question, please start with that. Now, draw the valence shell molecular orbital diagram for F2. Identify the following: the total number of valence electrons, the number of unpaired electrons, and the bond order. Note that if you know the number of unpaired electrons, you can also determine if it's paramagnetic or diamagnetic. If there's any unpaired electrons, it is paramagnetic. If there's no unpaired electrons, it's diamagnetic. So let's take a look here at how we can do this particular thing. So what we want to do is we want to first draw the atomic orbitals of both fluorines, and these are the valence shells, only the two, not the one. So fluorine has 7 valence electrons, so we can put in 1, 2, 3, 4, 5, 6, 7. Alright, note that when we have orbitals with the same energy, we fill them up, 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 down, down. Okay, this other fluorine is exactly the same. 1, 2, 3, 4, 5, 6, 7. So now we have our 2 atomic orbitals of fluorine. Then these atomic orbitals combine to form these molecular orbitals. Note, for the 2 atomic orbitals, we get 2 molecular orbitals, a bonding and an anti-bonding, constructive interference as a wave function, and destructive interference. For the 2 p's, we have 6, and we get 1, 2, 3, 4, 5, 6. So 3 from this one, 3 from this one, forms 6 molecular orbitals. Said another way, however many atomic orbitals you have, you get the same number of molecular orbitals. The other thing to notice here is that the sigma 2p for fluorine and oxygen is lower in energy than the pi 2p, which was for nitrogen and could be used for carbon as well. Typically you'd get this, alright, so you wouldn't have to memorize it, but let's take a look here. So when we do this, what we want to do is we want to put in our 4 electrons. So we put in 1, 2, 3, 4. Now for here, we want to put in 1, 2, 3, 4, 5 electrons plus another 5 electrons for a total of 10 electrons. So up, down, 2, up, up, 4, down, down, 6, up, up, 8, down, down, 10. So we've put in 2, 4, 6, 8, 10, 12, 14 total electrons. 7 from this, and 7 from this, and 7 from this. Or said another way, we put 4 in the 2s orbitals, and we put 10, 5 times 2 in the 2p orbitals. Alright, so that all the electrons from here going to here, there's a total of 14 electrons here, and a total of 14 electrons here. So total number of valence electrons in the diagram is 14 electrons. The number of unpaired electrons is again 0. So this would again be diamagnetic. Alright, if there were unpaired electrons, we could say it's paramagnetic, but in this case there aren't any. Bond order. So the bond order, as we talked about before, is the bonding electrons minus the anti-bonding electrons divided by 2. So in this case, the bonding, you can't see that. In this case, the bonding electrons is everything that doesn't have a star. So 2, 4, 6, 8. So we have 8 bonding electrons. I'm going to write up here so you can see it. Anti-bonding electrons are the ones with the stars. 2, 4, 6. Divided by 2, okay, is equal to 1. So the bond order is 1. In the previous example, we had nitrogen, which does have a triple bond. In this case, we have fluorine, diatomic fluorine, which does have a single bond.